this would be the epididymides. Now, if you look inside the testes, if you do a cross section, it looks like a lot of angel hair pasta that's just coiled in there, coil. And all along these sections, there are spermatogonia and spermatocytes that are being formed. So the reason that males can make so much is in the seminiferous tubules, which look like the angel hair pasta, there's constant spermatogenesis going on in terms of mitosis and meiosis. So it's constantly throughout in their two testes, so you can see that all along these tubules, it's a constant process. There are various stages of the process, so that, today you got your 300 million ready to go, tomorrow you got your 300 million ready to go, because this is very well orchestrated, and it's a constant and continuous process. Okay, so once the sperm cells leave the testes, we said 64 days, it goes, and I'll tell you this is the reedy testes, but don't worry about that. It goes to the epididymides, and it gains motility along here, and then back down to the vas deferens. So now let's look at a cross section of this. This is the seminiferous tubule. So sperm cells develop inside the seminiferous tubule. So where we are, we're just taking a little piece of one of these tubules and looking in cross section. Okay. So at this point, what you're seeing are the most mature sperm cells here, the most immature here, close to the basal membrane. All right, so when we're looking into the seminiferous tubule, the one thing we need to know is that the Sertoli cells are there, and they have a number of functions to help with the production of the sperm cells. The Sertoli cells are sometimes called the nurse or the guardian cells. They kind of nurse this whole process along. And one of the major things that the Sertoli cells do is to make these tight junctions. You cannot have any blood enter into the seminiferous tubule. If you do, spermatogenesis is over, it's finished. So the Sertoli cells form like a blood-testis barrier. So the blood products cannot, the blood cannot enter into the seminiferous tubule. The Leydig cells are outside of the tubule. They're in the interstitium. So they are not in the tubule. They're making the testosterone. They're making testosterone. And the testosterone then can diffuse through the membrane and get in, because you need high levels of testosterone for the sperm production. So the Leydig cells sit outside the tubule, but the testosterone that is made by the Leydig cells can diffuse into the tubule, and it's sequestered there. Okay, there's also high levels of potassium inside this tubule. So high levels of testosterone and potassium are there for sperm production. And we'll probably talk a little bit more about that. There are other functions of the Sertoli cell. Blood-testis barrier. They also produce something called androgen binding protein, which helps to sequester the testosterone inside the tubule. Androgen binding protein, blood-testis barrier. They're the nerve cells. They help this whole process. And they do other things too. There are a lot of things that the Sertoli cells do. Okay. Here we are taking this down now to see. As I said, this is the basal lamina or the basement membrane, the basal membrane. And outside in the interstitium are the Leydig cells. Now, testosterone can do one of two things. It can be, this is a classic endocrine thing, is that when the testosterone is made, it can diffuse out into the capillaries and circulate in the bloodstream. Because you know that males have to have secondary sexual characteristics. It's coming from this testosterone made by the Leydig cells that's flowing through the bloodstream to get the male type physique, the muscle mass, the deepening of the voice, all of the male secondary sexual characteristics provided by the testosterone from the Leydig cells. But also, as I said to you, the Leydig cells make testosterone, and this testosterone can diffuse through this membrane and it's going to be sequestered here by the androgen binding protein so that you can get sperm production. So the blood testis barrier is just the tight junctions between the Sertoli cells, and the Leydig cells make the testosterone. So go back in your book and review Sertoli cells in terms of their function. All right, so here we are with going from spermatogonium to spermatocytes to spermatids, and spermatozoa are the ones that are released, and we've gone through the epididymis and all of this, and we've acquired motility. So what we have now is a typical sperm cell. This is almost capable of fertilizing an egg. You see the acrosome that contains enzymes that's necessary for helping you penetrate the ovum. The nucleus, and then you develop this mitochondrial spiral, and this is your classic structure of the spermatozoa that is destined to be ejaculated. Okay. Semen is composed of both the sperm as well as the accessory sex gland secretions. So semen is the sperm and the secretions that the glands provide. Now, do I want you to memorize all of this? No. But there's one I want to call your attention to, and that's zinc. This is the one that's very critical, because if there's a deficiency, if a male has a deficiency in zinc, he's probably not going to be fertile. But what I want to just tell you is this, that a number of glands, you should just kind of know what the contents of semen is. There's mucus, there's some water, there's buffers. You got to buffer the vagina because the vagina is acidic. And if you don't buffer it, the cells will die, sperm cells will die. There are a number of nutrients in there that are provided by all of your accessory sex glands. Some enzymes that clot the semen in the vagina, and then they liquefy the clot. And prostaglandins are there for contractility to help the sperm be transported through the vaginal tract. Now, does everybody know that semen, when it's ejaculated, it clots first? Everybody knows that. Okay. It clots. It's like tapioca pudding. It's like so when it's deposited into the female tract, or if it's deposited into a clinical vial or what have you, initially it will clot. And you're doing that to just provide where the sperm will just kind of stay in place. And then after some time, remember we said that the clot would be provided here, that there are enzymes that causes a clot. And then after it gets to the place that it needs to be and is comfortable, then it can liquefy, and then the sperm cells can pretty much diffuse. Okay. Now that's all well and good. Now this is all textbook. Let me just, I'm going to say it. This is textbook. The body does not always work like textbook, because you would say that, okay, clot forms and it takes about 20 to 30 minutes for the clot to liquefy. So, you should be able to get rid of the sperm cells before then. No. Sometimes they can find sperm cells at the site of ovulation, at the site of fertilization, within minutes. Minutes. So all of the sperm cells, is what I'm telling you, don't necessarily stay in that particular clot. Okay? So, question for you. Acrosome, what does it do? Yeah, C. So lysosome-like vesicles that contains enzymes that are necessary for fertilization. Huh?
That's the longest answer.
That's not always the case. Don't do that on my exam, because I know that.
Can you go back, please? The lysosome vesicle.
No, it is,
I was just fixing.
Yeah, that's a good strategy, but it doesn't always work.
It's not 100%. When it's down, you go and see.
All right, so let's deal with the male. So we know that we got to make the testosterone for the body, male shape, the beard, the body hair, the muscular development, the vocal cords, the sex drive, anabolic, all of that good stuff. We need testosterone, all of that. So let's make sure we make it. And I just put up this blank thing. So where we're starting is the hypothalamus. What hormone do you think should be there?
GnRH.
All right. And the anterior pituitary. Now, here we're going to the Leydig cell. Which one would that be? LH or FSH? LH. Okay. If we're going to the Sertoli cell, what would that be? Okay, so GnRH from the hypothalamus, we're going to stimulate LH. LH is going to stimulate the Leydig cells to make what? Testosterone. FSH is going to stimulate the Sertoli cells for sperm production. Okay, and what else do I want to say about this? Oh, one other thing that the Sertoli cell can make is inhibin. INHIBIN, inhibin. And inhibin feeds back on FSH to shut it down. It's a negative feedback situation. Okay, so we'll come back to that. But for right now, let me talk to you about where we are in terms, we were making semen. I don't know how that got out of order. Anyway, let's talk about the semen analysis. So if you got a couple and they have not been able to have a child within a year, unprotected intercourse, within a year they're considered infertile. So the easiest of the two, or the easier of the two to work up is the male. First thing they can start with is, physical examination. They can also do a semen analysis. So, these are some of the things that they look at. The volume, liquefaction time. In other words, how long does it take that clot to dissolve? The sperm count. Are these sperm cells total? Are they viable? What's the morphology look like? And so, let's just talk about volume. The average ejaculate should be about 2 to 5 milliliters. So they're going to look at that volume. If the volume is low, then they begin to say, oh, might be a problem. So it should be 2 to 5 milliliters. The liquefaction time should be about 25 minutes or so, plus or minus 5 minutes. So in other words, once the sperm cell has clotted, it should take about 25 minutes for it to liquefy. If it takes longer or less time, then there may be a problem. The sperm count, what they want to see is at least 20 million cells per milliliter. Now, I've seen guys that have maybe 300 million per milliliter. They're producing, these were young medical students. And they were getting paid. And so they can have about 300 million, some of the healthy males. But you want a minimum of 20 million per milliliter. You want them to be about 50% modal. In other words, when I'm talking about motility, I'm talking about forward progression. Because we see other types, but you want them to be moving forward, moving forward, moving forward. So you want about 50% of them to do that. Viability, you want about 50% of them to be alive, because some of them are going to be dead. And the morphology, you want about at least 30% to have normal morphology. Now, when I'm talking about normal morphology, it's the acrosome with the tail and all of that. But we call it pinheads, where you just have the tail with no nucleus and acrosome. Call them pinheads. So you can definitely have that. Something snapped the nucleus off. So those are some of the things. Other things they look for would be